This lecture is about solving equations with trigonometry. But before we start getting to some of these equations, I want to remind us of some things and add to a couple of these. So one of the trig identities that is very useful is sine squared plus cosine squared is equal to 1. And I can also alter this a little bit if I divide, so this is one identity, right? I can take this and divide everything. If I take sine squared plus cosine squared equals 1, and I divide it by, let's start with sine squared. I'm going to divide everything by sine squared. This produces me a new identity, and this one is 1, right? Sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared equals 1 over sine squared is cosecant squared x. So here is another identity, okay? And then I can also take this, I'll go back to this one again, and this time divide everything by cosine, and that one gives us our third one. So sine squared x plus cosine squared x equals 1. I'm going to divide everything this time by cosine squared. Now there's a million different trig identities. Just Google them and you'll see that there's a whole bunch of them. But this is some of the most useful ones. I'm not going to introduce too many until we actually need them. All right, so this is going to be, so sine over cosine is tangent. So this is tangent squared plus 1, cosine over cosine is 1, equals 1 over cosine squared, which is secant squared x. So we get 3 different identities, oops, that's not one, out of this one. So this one comes from the Pythagorean theorem, right? Because the two sides of a triangle, when you square them, it's equal to the hypotenuse, and in the unit circle, the hypotenuse is always 1. And then if I divide that one by sine squared, I get this one, and if I divide it by cosine squared, I get this one. So you want to keep these sort of in the back of my mind. Now, I always remember just this one, and then I create these when I need them, but because I can't remember all these different things. But all right, so let's start with our first one. So we're going to start with a couple of very simple ones where we don't have to do much work. We do have to know our unit circle, however. So if we have the sine of x equals a half, right? So here's the rule of thumb. If you can find the exact value, you should, okay? I know that we can approximate and we can use arcsine and things like that, but when it's most of the time it's going to say find the exact value. And exact means I'm going to have to use the pi over whatever and not just the decimal approximation. Okay, so this means I'm going to need my unit circle. Now I remember that sine of something is a half is always some version of pi over 6, okay? So I think I'm going to have multiples of pi over 6, and pi over 6 itself will work because this is positive. Now, thinking of my unit circle, right, sine is y, and so that means that this one here, this is the pi over 6, right, and y is positive over here as well. Y is negative in both the second and third. So my two answers will be pi over 6 and 5 pi over 6, because those both give me a half. These down here will both give me a negative a half, and I only have a positive. And let's put the condition on it that we're staying between 0 and 2 pi here, or else I can write a whole bunch of them, right? Because I'd have pi over 6 plus another 2 pi plus another 2 pi and all that. So these are the only two values that fall between 0 and 2 pi. All right, so let's do a cosine one as well. So if I have the cosine of x is negative square root of 3 over 2, okay? So I know actually it's going to be another version of pi over 6, right? Because if sine is a half, right, the cosine, these kind of go together, except this is negative. So I know that this is going to be some version of pi over 6. Now pi over 6 is not going to be an answer in this time, because pi over 6 would give me positive 3. This would be here, it would be positive square root of 3 over 2. So cosine is negative over here, right, and down here. So this one is 5 pi over 6, and This one down here is 7 pi over 6. If you can't remember, just count around them, right? It's kind of like 1 pi over 6, 2 pi over 6 is really pi over 3, 3 pi over 3 is really pi or and 3 pi over 6 is pi over 2, so that's here. 4 pi over 6 is really 2 pi over 3, and then I get to 5 pi over 6. And then I know 6 pi over 6 is pi, and then 7 pi over 6. So, I mean, everything else is going to simplify except for these 4 that I need. And these are the only 2 that are negative, so these are my answers, okay? Now, I know that if I put arc cos of this in there, it's going to give me decimal approximations, but I want these values. Exact values mean these values. All right, so let's do something a little bit more challenging. I have 4 sine squared of theta minus 3 equals 0. Okay, so I kind of want to think of this as like a giant X, my sine squared. So if I only have one trig value here, in which I only have sine squared, then I want to solve for that. Okay, so the first thing I'm going to do is add 3 to both sides. So I have 4 sine squared of theta equals 3, and I'm going to divide by 4. So I get sine squared of theta is equal to 3/4. And so now to get rid of the squared, I'm going to take the square root of both sides, also putting plus and minus. So now I have sine of theta is equal to plus and minus. I'm going to take the square root of the top and bottom, so square root of 3 over 2. Aha! So this is also a trig value that we know, right? You should know that this is familiar, square root of 3 over 2. And I know that when I have the sine is square root of 3 over 2, it's multiples of pi over 3. And since I get plus and minus them, I'm going to have all of them. And I'm going to stay in this I'm going to stay between 0 and 2 pi here. So that would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all the values between 0 and 2 pi. There are my values. So I really do need to know my trig values here. Okay, so let's do a secant. I have the secant of theta is equal to 2. Now, there is no arc secant on your calculator, so we really need to switch this into its original. So I'm going to say 1 over cosine of theta is equal to, I'm going to treat this like an integer, right? I'm going to put it over 1. So what I'm going to do, right, if this is equal, then the reciprocal will also be equal. So I'm literally just going to flip both sides and call this cosine of theta equals 1 over 2. Now this is something I can deal with because I do know that cosine of theta is a half. That's some exact trig values that I know. So theta will be then, let's see, cosine of theta is a half at multiples of pi over 3. I always for some reason I always remember that sine of theta is a half, so I know that cosine of theta is a half must be the pi over 3 version. Okay, so pi over 3 would be positive, and then cosine is positive in the first quadrant and in the fourth quadrant. So the one that would be in the fourth quadrant would be 5 pi over 3. Okay, so those are my theta values. So theta is equal to these. Okay, so let's look at another different one. So we're starting off kind of with the slightly easier ones. If I have the cosecant of theta is equal to 5, I'm going to do the same thing that I did last time. This is 1 over the sine of theta. Remember, there's one c and one s in each pairing, is equal to 5. So that means that the sine of theta is equal to 1/5. Just doing the reciprocal of both sides. Now this really isn't a value that I know, and so I'm going to have to use my arc, right? I want to know what theta is, so I know that the arc sine of 1/5, I put this in my calculator, and in radians, I get 0.201, right? If I was desperate to know in degrees, it's 11.53 degrees. All right, so let's move up a little bit in difficulty. I have 2 cosine squared of x plus the cosine of x equals 0. All right, so factoring really just never goes away here, right? So I can think of this, right? This has cosine squared, this one has cosine, so I can factor, right? I have it equal to 0, so I can always use factoring as a way to use my zero product property. So I can factor out a cosine here, because they both have at least 1 in common. And then this inside will be 2 cosine of x plus 1 equals 0. And now I can set these equal to 0 separately. I have the cosine of x is equal to 0, and the 2 cosine of x plus 1 is also equal to 0. We're going to keep our answers again between 0 and x and 2 pi. I don't want to, we'll just stay in that interval here. So the cosine of x is 0 at, let's see, so let's just, right, the cosine is 0 here, which is at pi over 2, and here, which is at positive 3 pi over 2, right? I could say that this is negative pi over 2, but that's not in my interval. I'm only going from 0 to 2 pi. So I know that this one gives me x equals pi over 2, and this one gives me, and 3 pi over 2 as well. And then I want to solve this one as well, so I'm going to have to move the 1 to the other side. 2 cosine of x equals negative 1. I divide by 2, and I get the cosine of x is negative 1/2. I know that that must be some version of a pi over 3. Cosine is negative in quadrants 2 and 3 because they're the x quadrant, right? So that would be 2 pi over 3. That's up over here. And then this one would be 4 pi over 3. So I have 4 different values. Okay. All right. So let's step up our factoring a little bit. So we have 2 sine squared theta plus 3 sine of theta plus 1 equals 0. And again, we'll keep 0 between theta between 0 and 2 pi. Oops. Okay, so there's my problem. Well, let's see. It kind of looks like I could factor it, right? If I think of the sine of theta as x, let's rewrite this so it makes it a little less complicated. This would be 2x squared plus 3x plus 1 equals 0. Okay, I think this factors, right? It would be 2x, and this is a plus, so both plus 1 equals 0. Do I get the middle term? I get 1x, 2x. I do. So I have 2x plus 1 equals 0, and x plus 1 equals 0. So I'm going to go ahead and solve for x. This one will give me x equals negative 1/2, and this one will give me x equals negative 1. And now I put my sign back in for x. So the sine of theta is equal to negative 1/2, and the sine of theta is equal to negative 1. Sine of theta is negative 1 between 0 and 2 pi at, let's see, at 3 pi over 2. That's straight down. And sine of theta is negative 1/2. Those are multiples of pi over 6, and they would be in the 3rd and 4th quadrants. So that would be 5 pi over 6 and 7 pi over 6. So I have 3 theta values. Okay. All right. So let's do one that's, we're going to have to use an identity for this time. How about if we have sine squared of theta minus 2 cosine of theta plus 2 equals 0. We'll keep them, we're going to keep our same restriction that theta will be between 0 and 2 pi. Okay, so this one I can't factor because in the other one I had a sine in the middle and sine squared. Now I can't change this one, but I do have an identity that says that sine squared plus cosine squared equals 1. And so I can replace sine squared. So let's solve for sine squared. Sine squared of x is equal to 1 minus cosine squared of x. So instead of sine squared over here, we're going to replace it with 1 minus cosine squared. Because I can't change the middle term, but I can change the squared term. So we always want to change it to whatever the middle term is, the one that's not squared. So sine squared becomes 1 minus the cosine squared of x minus 2 cosine of x, or I'm sorry, I'll keep theta, sorry, I switched variables there in the middle. Theta plus 2 equals 0. All right, so I can add this 1 and this 2 together. So now I have negative cosine squared theta minus 2 cosine theta plus 3 equals 0. All right, so this is just like if I had a x squared, I wouldn't want to factor with the negative x squared in the front. So I'm going to multiply all my terms by negative 1. So that means I'll have cosine squared theta plus 2 cosine theta minus 3 equals 0. So I just multiplied everything by negative 1. All right, so let's change this. So this time we'll say x is the cosine of theta. So this is x squared plus 2x minus 3 equals 0. All right, I got another factorable one, and that would be x minus 3 times x plus 1. That gives me, oh, nope, that's not right at all. How about x plus 3 times x minus 1? There we go. Now I'm going to get the positive 2x in the middle with the positive 3x minus 1 equals 0. So I get x equals negative 3 and x equals 1. So I'm going to put my cosine back now. The cosine of theta is negative 3 and the cosine of theta is 1. Now, cosine of theta equals negative 3 does not exist because all cosine values, when you put in a theta value, you only get values between 1 and negative 1. So this one has no solution. Now, cosine of theta equals 1, that would be at 0 and 2 pi both. And since I'll say I'm using between 0 and 2 pi and they're included, then both 0 and 2 pi have a cosine of theta that's equal to 1. So those are my two solutions. Okay, so let me do one more of these. So what if I have one that doesn't factor? Okay, so I'll have sine squared minus sine minus 1 equals 0. All right, if I think of this as, oh, I used x instead. So let me say y is equal to the sine of x. So I'll have y squared minus y minus 1 equals 0. Now, this I don't think is going to factor because if I try it, I would have to have y plus 1, y minus 1 to get the negative 1 here. But then when I do that, the middle term cancels out. So this does not factor. But since this here is a quadratic, I can still use it. So in this case, I have a is 1, b is negative 1, and c is also negative 1. So my quadratic goes x equals negative b, so this will be positive 1, plus or minus the square root of b squared, which is 1, minus 4 times a, which is 1, times c, which is negative 1, over 2. So my x will be x equals 1 plus or minus the square root of, this will become 1 plus 4 because of this minus sign, so this is the square root of 5 over 2. Okay, so basically now I have that the sine of x is equal to, oops, sorry, this should have been y, because I had it in y. So sine of x is equal to 1 plus or minus the square root of 5 over 2. So that means I'm going to now need my arc sine. So I have the arc sine of, I'm going to break these apart as 1 plus the square root of 5 over 2, and the arc sine of 1 minus the square root of 5 over 2. Now when I put this one in my calculator, 1 plus the square root of 5, 5 is really slightly bigger than 2, right? Because the square root of 4 would be 2. So this actually is going to be larger than 1. So when I put this in my calculator, I got basically that it was undefined. So this is no solution. This is not a solution, right? Or I'll just say that's not one. But when I put this one in, 1 minus the square root of 5, I did in fact get a radian value of negative 0.667 radians. If you're desperate to know what it is in degrees, it's also approximately 38.17 degrees. Okay, so I can, in fact, use the quadratic formula on this. So, as I said before, factoring in using quadratics, it's just the gift that keeps on giving. So that's some of the examples of trig functions that we can solve.